Hi, my name is Kimberly Ennico. I'm a staff scientist at NASA Ames Research Center, and I'm presenting a poster on our instrument called NIRVSS, the Near-Infrared Volatile Spectrometer System. It is one instrument of several aboard the Resolve payload, which when packaged with a rover can be exploring volatile deposits at the lunar poles. As I quickly step you through our poster, if you have any questions, feel free to email me. My email is shown in the blue font in the author list. So NIRVSS, our near-infrared volatile spectrometer system, consists of two parts on the Resolve payload: a bracket assembly, which has our lamp illumination scene, a camera, long wavelength calibration sensors, and the fiber inputs to our spectrometers. Shown in the middle here on the top is our bracket assembly in white and the field of view on the lunar surface, where we show with a drill that we are observing the drill location site. Our spectrometer module is located in the top at a different part on the Resolve. We also summarize our science requirements for our instruments and how they trace to the Resolve payload. I also wanted to point out that a mission called Resource Prospector, which utilizes the Resolve payload on a rover platform, is an oral talk during the Lunar Science Forum this Thursday, July 18th, in Section 6B from 1:30 to 1:45 p.m. Tony Colprete at NASA Ames Research Center will give the talk. The middle left of the poster gives a top-level description of Resolve with its main instruments and points of contact. The middle of the poster describes our NIRVSS science requirements that led to measurement requirements such as wavelength coverage, spectral resolution, correcting for the thermal background, and our spatial resolution on our drill operations camera. The bottom of our poster describes our instrument in a little bit more detail. Our spectrometer derives flight heritage from the NLSI near-infrared spectrometers. We have some slight differences. One important one is we've extended our wavelength coverage out to 3.4 microns. The NLSI instruments stopped at 2.5 microns. By extending our wavelength coverage, we now have the ability to measure water in multiple bands at 2 microns and 3 microns, plus better identification of other volatiles that we hope to see. I should note that there's another instrument on the Resolve payload called LAVA, which has a GCMS, which will actually measure the amounts of each of the volatiles in much higher fidelity than our spectrometer. Our spectrometer is designed to measure the amount of water and also measure the form of water, and do it while roving to identify the places where we need to drill, and also while drilling. The bottom right of the poster summarizes testing that has been going on at NASA Ames to make this engineering test unit viable for flight. Environmental testing like thermal vacuum and vibration testing. And we've also started doing performance measurement, and this testing has just started underway.